Hi guys, and welcome back to another capacitors calculation. We will now be having a look at calculating capacitors in parallel. I have already drawn the circuit, as you can see. There's the circuit, and done the calculation just to not waste any time on the length of the video. First, before we go into the circuit and the calculations, just the pyramid again. They have drawn the pyramid, and again you can derive the formula from the pyramid. This is why this is very important. Right, so if you don't know how to do this, let me just explain. If you need to calculate your charge will be equals to my capacitance times my voltage. If you want to calculate the voltage, it is the capacitance divided by the my charge divided by the capacitance, and my capacitance will be my charge divided by my voltage. Again, here I'm just showing here with the arrow. If however your capacitance value and your voltage value is unknown in a specific problem or calculation, and the current and the time is given, you can also calculate your charge with that. Alright, now let's go into the calculation. Here I have my circuit. I have my 12 volt supply. I'm going to calculate what is my, there's my capacitance, 10 microfarad for C1 and 4 microfarad for C2, right? Voltage drop V1 and voltage drop V2. Just about this voltage drop here, the voltage drop V1 and V2, you don't need to calculate because we are working with a parallel circuit, which means the voltage drop of V1 will be 12 and the voltage drop for V2 will also be 12, right? And that is because we're working with a parallel circuit. So the first thing that you will be calculating is calculating the total capacitance of the circuit, and that is going to be C1 plus C2, which will give me 14 microfarad at the end of the day. Next thing that you will be calculating is calculating the total charge of the circuit. And if you can see here, if I need to derive the formula from my pyramid, charge is equals to my capacitance times my voltage, and that is exactly what it is here. In this case, I'm going to say my total capacitance times my total voltage because I want the total charge of the whole circuit. And that is going to be 168 microcoulomb. Next, I'm going to calculate what is the charge in capacitor C1 and what is the charge in capacitor C2. And that is going to be my capacitance multiplied by my voltage V1, which is 12 volt because it's parallel, which will give me 120 microcoulomb. Same here, my capacitance of C2, 4 microfarad, multiplied by 12, which is my voltage, which will give me 48 microcoulomb. Right, and if you add these two together, you're going to get what is my total charge of my circuit, and that is whereby you can see that in a parallel circuit we actually have different charges, and the reason for that is parallel. The circuit is in parallel, so I'm going to have a charge over C1 and I'm going to have a charge in C2, whilst for the series circuit I only have one charge because it's a series circuit. Now here I'm just explaining here what I've explained to you in this case, in the sense of the charges, that in actual fact C1 plus C2 is going to give me my total charge. And then in this block I'm also just explaining that my total voltage is equals to V1, which is equals to V2, because I'm sitting with a parallel circuit, right? And there I have proven that if you want to calculate your voltage V1 and you take your first capacitor's charge divided by the capacitance, you actually get 12 volt. Same with V2, your second capacitor's charge divided by the capacitance will give me 12 volt, which proves that in a parallel circuit my total voltage is equals to V1, which is equals to V2. Right. Last but not least, we're going to go to the energy stored in the circuit. And you can see when I calculate my energy stored in the circuit, which means the total energy, I must have the total capacitance in the circuit as well as for the total voltage squared in the circuit. And I'm going to get a value of 1.008 millijoules. Alright, if you need to calculate the energy for capacitor C1 and capacitor C2, that's going to be my half of my capacitor C1 multiplied by my voltage squared, which will give me 0.72 millijoules, and the same for this one, capacitor C2 multiplied by my voltage squared, which is 144, and I'm going to get 0.288 millijoule. Now again, if you add these two energies together, you must get what is the total energy. If you don't get that, if they don't add up to each other in the sense of giving you the total energy again, then somewhere along the line you have made a mistake. So be very careful and take note of what you do when you do these calculations. And then that, guys, that is how you calculate capacitors in parallel. Thanks for watching.